Today we're going to learn about a special type of right triangle, the 45, 45, 90 triangle. So this triangle and then the second special right triangle that we're going to learn about will be hugely important for the rest of your math career. So they'll really play a role in pre-cal and calculus. So this is one of the concepts from geometry that will be essential moving forward in your math career. So let's say we have a 45, 45, 90 triangle. So it's a right triangle and two of its angles are congruent, which means it's an isosceles triangle. So sometimes you'll hear this called the 45, 45, 90 triangle. Other times it's an isosceles right triangle. Those mean the same thing because if it's a right triangle and it's isosceles, the two base angles have to be 45 degrees. So these two legs are going to be congruent by the converse of the isosceles triangle theorem. If those base angles are congruent, then those sides are congruent. So if I call this side x, these two legs are going to be congruent, so this side will also be x. So let's say I wanted to find the length of this hypotenuse. I would do Pythagorean theorem. This is a right triangle. I know two of the legs. I'm missing the hypotenuse. I can do a squared plus b squared equals c squared. So I'm going to call the hypotenuse c for now. So a squared x squared plus my other leg x squared should be equal to the hypotenuse squared, c squared. I have like terms right here. I have 1x squared plus 1x squared. So I can combine those to get 2x squared. So 2x squared equals c squared. And so I am trying to solve for c. So I currently have c squared. I want to just have c all by itself. So the way I'm going to do that is by taking the square root of c squared. So I can't just take the square root of the right side of the equation unless I also take the square root of the left side of the equation. Okay, so on the right side, the square root of c squared is just going to be c. Remember, the square root and the square essentially cancel each other out. Or you can think of c squared as c times c. You circle the c's, you bring the c out front, and there's nothing left underneath. So the square root of c squared is just c squared. And so now, if I'm thinking about the square root of 2x squared, this is the same thing as 2 times x times x. So I can circle my x's. I can bring an x out front, but I have this 2 left over. I don't know what the square root of 2 is. It's not a perfect square, so that gets stuck underneath the square root. So the moral of the story is, in every 45, 45, 90 triangle, it doesn't matter how big it is, how small it is, if its angles are 45 degrees, and 90 degrees, the sides will always be in the same ratio, x to x root 2. So the two legs will be x, and the hypotenuse will be x root 2. So what this means is x, the length of this leg, can be anything. It could be 50, it could be 3, it could be root 5, it could be whatever. But once I determine what the legs are, that will influence what the hypotenuse is. The three sides are always going to be in this ratio, in this relationship, x to x root 2. Again, it can be for a really small 45, 45, 90 triangle or for a really big 45, 45, 90 triangle, but the sides will always have this relationship. So this is what you're going to need to memorize, this little chart right here. So I'm not going to use x to represent the sides moving forward because sometimes, like, I might say find x and I'm talking about a particular side. So we're going to use a different variable. We're going to use s for side. So if I say the side across from the 45 degree angle is s, then that means the side across from the other 45 degree angle will also be s. And then we just learned s, the hypotenuse is going to be s square root of 2. So you have to have this relationship, this picture memorized. You should be able to recreate it. You should also be able to recreate this chart. If it's a 40, here, I'm going to put the angles at the top, 45, 45, and 90. The side across from the 45 degree angle is s. The side across from the other 45 degree angle is also going to be s. And then the side across from the 90 degree angle is going to be s root 2. So we're going to use this chart. Sometimes I'm going to give you different side measures, side lengths, and so then we can go plug the ones that we know into the chart, and so it will help us solve for the ones that we don't know. So again, across from the 45 is S, across from the 45 is S, across from the 90 is S root 2. So you should have S, S, S root 2, S, S, S root 2, S, S, S root 2. S, S, S root 2. Leg, hypotenuse, S, S, S root 2. Have that memorized. We're not going to give you that on a test or a quiz. Let's do an example. Okay, so we have this 45, 45, 90 triangle. And I know across from 45 is S, S, and across from 90 is S root 2. I know that one of the sides across from my 45-degree angle is 8. So I'm going to go put 8 in the box in the chart. Across from the 45 is 8. So that means that across from the other 45-degree angle, that side will also be 8 because it's also S. So this is an 8 as well. If S is 8, 8, 8, well, what is the side across from the right angle going to be? 8, 8. And if I'm just going to go plug 8 in for S, this is going to be 8 root 2. 8, 8, 8 root 2. I'm literally just, I know S is 8, so I'm just going to go plug 8 in for S. So X is going to be 8 root 2. Okay, second right triangle. Across from the 45 is S, S, S root 2. So let's think about which side we do know. On this triangle, we know that the hypotenuse is 3 root 2. We know the side across from the 90-degree angle is 3 root 2. So I'm going to go plug 3 root 2 into this box in the chart. So I don't know what S is, but I do know that S root 2 is equal to 3 root 2. I know that the hypotenuse is 3 root 2. So you might not have to set up this equation. You might just be able to see it in the chart, but I'm trying to solve for S. I want to get S all by itself. So I'm going to divide by root 2 on both sides to get S all by itself. The root 2's cancel out, leaving me with just S is 3. And you might have been able to notice that right here. If you just think about it in the chart, if you just cancel out the root 2's, then S is 3. So S is 3, S is 3, 3, 3, 3 root 2, X is equal to 3.